Today we are going to dive into our first lesson of Unit 2. However, before we do that, I do have a few announcements. The first being that we will not be meeting via Google Meets tomorrow. This is on Friday, October the 9th. We will not be meeting via Google Meets tomorrow on Friday, October the 9th. This specifically applies to my first, second, and fifth period class, as my third period class and I do not ever meet on Fridays. There is also no school on Monday, October 12th, so we will not be meeting via Google Meets on Monday. The reason that we will not be having school and we will not be meeting on Monday is because Monday, October 12th is Columbus Day, which is considered a holiday. However, you will be engaging in an asynchronous activity on Tuesday, October 13th. That means that you will not be coming to school on Friday, you will not be coming to school on Monday, but you will be responsible for logging on Tuesday to complete that assignment. The next announcement that I have is that zeros will be going into the gradebook for all missing Introduction and Unit 1 assignments starting on Monday, October 12th. This will happen at 11:59 p.m. After 11:59 p.m. on Monday, October 12th, you will see zeros being reflected in the gradebook. This means to please check the assignment tracker so that you can see what you are missing and what you need to turn in. Right now, on your progress report number 1, you did see a very high grade. This is because if you were missing any assignments, I just marked off missing assignment and did not input a 0. However, once I start inputting those zeros, your grade will significantly go down if you do not submit those assignments, specifically those assignments from the Introduction and Unit 1, by Monday, October 12th. If you have any questions or concerns about this, please reach out. Today is Tuesday, September 8th. Today's objectives are students will be able to develop the definition of a reflection using constructions. Students will be able to describe the properties of and write rules for reflections, and students will be able to determine the image and pre-image of a figure after a given reflection. This is part of Unit 2, Lesson 1. Before we dive into that, please pause the video now to complete the Do Now. Welcome back. Now that you've completed that Do Now, I can mark you present for attendance. Let us dive into today's lesson. Today's lesson is titled Reflections, and once again, this is Unit 2, Lesson 1. At the end of this lesson, you should be able to answer this question. The question is, how are reflections described mathematically? We are specifically focused on how reflections are described mathematically. In the real world, we may think of reflections as a reflection in a mirror. However, in math, reflections are described in a very different way, and at the end of this lesson, you should be able to answer this question. Let's look first at what rigid transformations are. You may have seen this term before in Algebra 1, or you may have not. For that reason, we are going to review rigid transformations. A rigid transformation preserves the size, length, shape, lines, and angle measures of a figure. Preserves means does not change. This means that the pre-image and image are congruent. There are 3 types of rigid transformations, and those are reflections, translations, and rotations. In today's lesson, we will be reviewing reflections, and we will get into translations and rotations later on next week. Here's one example of a rigid transformation. As we know, rigid transformations do not change the size, length, or shape of an image. As we see here, we have this tile. If I move this tile from here to here, that tile does not increase in size, shape, or length. It remains exactly the same. This is an example of a rigid transformation. So let's look at this example. This question is asking us, Is the transformation a rigid transformation? Well, this is the image that we start with. As we can see here, we have our pre-image. We know that this is our pre-image because it does not contain that prime notation. Pre-images do not contain the prime notation that we see here. This shape would be our pre-image. The image that does in fact contain that prime notation that we see here is known as our image. How can we remember this? Well, pre means before. So this is our image that happens before we take on any type of transformation. In order to determine if this transformation that we see here is a rigid transformation, we would have to determine that all of the line segments are congruent, all of the angle measures are congruent, and that the size and shape is not altered. So in order for this to be a rigid transformation, all the line segments must be congruent. Well, these different symbols tell us that those line segments are in fact congruent from the pre-image to the image. Another criteria is that all the angle measures must be congruent. Well, these type of symbols tell us that those angle measures are in fact congruent from the pre-image to the image. Therefore, because we can conclude that all the line segments are congruent and all the angle measures are congruent, we can conclude that this transformation is in fact a rigid transformation. So what exactly is a reflection? Well, a reflection is also often referred to as a flip in a frame. For example, we can see here that this pre-image is reflected across this line to create this image. In a reflection, all points of the pre-image are reflected across a line of reflection to produce that image. So as we can see here, we have our pre-image, which is reflected across a line. Specifically, this is our line of reflection, which then creates our image. So, once again, in a reflection, all points of the pre-image are reflected across a line of reflection to produce the image. This reflection is notated like this. This notation tells us that triangle ABC maps is reflected by this arrow to triangle A prime, B prime, and C prime. Reflection is a transformation such that the line of reflection is perpendicular bisect of the line segment connecting a point in the pre-image with the corresponding image. So, the line of reflection is the perpendicular bisector of the line segment connecting a point in the pre-image with the corresponding image. For example, we have here one point in the pre-image and we have here one point in the image. If we created a line segment between those 2 points, we could notate that line segment as segment B and B prime. Well, that segment B and B prime is perpendicularly bisected by the line of reflection. In this instance, our line of reflection is line EG. What is this telling us? Well, this is telling us that line segment B and B prime, and line of reflection, which is line E and G, are perpendicular to each other, which means they intersect at a 90-degree angle. This is also the case for line segment A and A prime, and the line of reflection, once again, E and G, as well as line segment H and H prime, which again is perpendicular to that line of reflection, E and G, meaning that each of those points intersect at a 90-degree angle. A reflection is a transformation also such any pre-image point that lies on the line of reflection is mapped to itself. C lies on that line of reflection, and so that means that the C prime will also lie on that line of reflection. What does that mean? Well, that C remains the same in both the pre-image and the image. Once again, if a point lies on the line of reflection, in this case, line EG, well, then that point remains the same. We're now going to look at different properties of reflections. Reflections always preserve the segment lengths and angle measures. However, reflections do not preserve orientation. What does this mean? Well, as we can see here, the segment lengths remain the same from the pre-image to the image. The angle measures also remain the same from the pre-image to the image. However, the orientation is different. Here I have different examples of how points are plotted on a coordinate graph. You may remember this from Algebra 1. You can plot different points on this coordinate graph the same way that you can plot different shapes on this coordinate graph. However, let's do a brief review. Let's say I wanted to create a point right here. In order to find the coordinates of that point, I would first look at our x-axis and identify at what coordinate point does that point lie. So we see here that that point lies at -6. Then we will look at our y-axis. We can identify that this point is also located at -2. Therefore, the coordinates of this point that we created here is -6 and -2. The same thing goes for this point. We see that this point is located on coordinate 1, y-axis 1, so we get coordinates 1 and 1 for that point. Here we get coordinates 4 and 4. Now, reflections can occur over different lines. We're first going to look at reflections across the x-axis. In this image, we see triangle ABC, which has been reflected across the x-axis to create triangle A prime, B prime, C prime. So we saw our pre-image, being reflected across the x-axis to create our image. Well, whenever a image is reflected across the x-axis, the x-coordinate always remains the same and the y-coordinate is negated. So the x-coordinate remains the same while the y-coordinate is negated. The rule looks like this for a reflection across the x-axis. R indicates reflection over x-axis. And then we take the original coordinates, but we negate the y. Well, what does this look like? Well, let's see. In the pre-image, we can see the vertex B is located at -1 and 5. So we have B at -1 and 5. According to the rule of the reflection across the x-axis, we can conclude that B prime, which is our image, when it is reflected across the x-axis, is actually going to change to become located at -1 and -5. As we can see here, the only thing that changed in this instance is that original 5 became a -5, because when we have a reflection across the y-axis, it is only the y-coordinate that is negated. The x-coordinate, on the other hand, is unchanged and remains the same. This is the case for every single vertex that we see on this pre-image. So for example, vertex C, when we get a reflection across the x-axis, we negate the y, giving us a -1. And for vertex A, we negate the y, giving us a -2. Now we're going to look at reflections across the y-axis. Here we see a trapezoid KLMN that has been reflected across the y-axis. To create the image K prime, L prime, M prime, and N prime, let us remember the trapezoid KLMN is our pre-image, and trapezoid K prime, L prime, M prime, and N prime is our image. So when we reflect that pre-image across the y-axis to get our image, we have a different kind of rule. In our reflection across the y-axis remains the same, but the x-axis is negated. So the reflection rule looks like reflection, y-axis, negation of the x. So what does this look like in this image? Well, here we see that we have K in the pre-image located at -1 and 3. And so in order to get our image vertex, we would negate the x-axis and leave the y-axis the same, giving us K prime is at 1 and 3. So we can see here that we did a negation of the x. It's important to note that negation of a negative number is a positive number, and that the negation of a positive number is a negative number. So in this case, we have the negation of a negative number, which becomes a positive number. In this case, we have the negation of a positive number, which becomes a negative number, the negation of a negative number, which becomes a positive number, and so on. And so in order to find the coordinates of the image, we would keep the y same, but the x values would be negated. We also have another type of reflection, and this is the reflection across y equals x or x equals y. As we can see here, we have triangle DEF. Triangle DEF is again our pre-image, and triangle D prime, E prime, and F prime is considered our image. So here we have another type of reflection, that is the reflection over x equals y. This is that reflection. So in this instance, we have triangle DEF, the pre-image, being reflected across y equals x or x equals y to create the triangle D prime, E prime, and F prime. In this instance, the y and x coordinates are switched. Therefore, the rule for the reflection across the y equals x axis is reflection x equals y, and then you switch x and y to find the coordinates of the image. So for example, here our pre-image has its D vertex on 2 and -4. Well, the D prime vertex on the image would become -4 and 2. As you can see, we have switched around the x and y coordinate to find the coordinate of our prime image. Same thing goes for vertex E. This x becomes the y, and this y becomes the x. This x becomes the y, and this y becomes the x. That is our rules of reflection across the x equals y axis. Here is our next type of reflection. This is the reflection across the line y equals -x. Here is our line y equals -x. As you can see here, we take our pre-image that is triangle ABC and create our image, which is triangle A prime, B prime, and C prime. And we take our pre-image and we reflect that across the y equals -x. In doing so, the x and y coordinates are switched and they are both negated. This means that when we have a reflection of y equals -x, the x and y coordinates are in fact switched, and then after they are switched, they are negated. So, for example, here we have vertex A, which in our pre-image is equal to -4, -5, but in our image after reflection, y equals -x becomes 5 and 4. So as you can see there, we switched our x and y axis, and then after we switched it, we negated it. Remember, when we negate, the negative becomes a positive and the positive becomes a negative. So here we have two negatives which become positive. So today we learned about the different kinds of reflections that we can have. We can have a reflection across the x-axis, a reflection across the y-axis, reflection across y equals x, and a reflection across y equals -x. This tells us different rules. For example, when we have a reflection over the x-axis, we negate the y. When we have a reflection over the y-axis, we negate the x. When we have a negation over y equals x, we switch y and x around. And when we have a negation over y equals -x, we switch y and x around and then negate them. Here are the terms that we learned today. We learned what an image is. That is the result of a transformation. We learned what the line of reflection is, what a perpendicular bisector is, what a pre-image is. Remember, that's what happens before a transformation occurs. We defined reflection, and we learned what a rivet transformation is. So now you should be able to answer how a reflection is described mathematically. An example of this answer is reflections are described using a rule that shows how each coordinate in the pre-image is mapped to the image. For example, when we have a reflection over y equals -x, we know that we need to switch those coordinates around and then negate them. So that is how reflections are described mathematically.